All right. Today I'm going to be taking you on a topic called significant figure. Okay. The reason why I wanted to dwell into this topic is because I found out that most students used to mix this significant figure with other kind of approximation that they do, like decimal place and to the nearest whole number and all of that. Significant figure is different. Okay. We usually mix it a lot. So I'm going to explain it in this video. So just write on with me. Okay. So I'm going to start with the definition of significant figure. But what is significant figure all about? Yes, significant figure adjusts the positioning of non-zero digits in a numeral. When you say non-zero digits, it actually means numbers that are not zero. It actually makes numbers like 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are non-zero digit numbers. Okay? Those are significant figure. They are all significant except 0. That is the meaning. Alright? And the non-zero digits, like I said, are 1, 2, 3, 4, 5, 6, 7, 8, and 9. They are non-zeros. Okay? And it is different from decimal place. So you don't have to mix it up. Decimal place, it is quite different from decimal place. In decimal place, you have to approximate all the way from the back. You have to round off numbers. If you don't understand about rounding off numbers meaning that if a number is exactly 4, okay, and I want to round it off to the next number, then this 4, since it is not up to 5, it is just 4. So any number lesser than 5 would be zeroed off. And then the next one will just stand the way it is. Like this 3 right here. 3 is going to stand the way it is. It is not going to change. Or if I have to, let's say I'm dealing with 5. So if I'm dealing with 5, I'm going to change this 5 to 0, and then I'm going to add 1 to this 4. And then this 4 becomes 5, whereas this 5 is now 0. That's how you do the approximation. Okay? Then that's not the end of it. Now if let's say it is 2 I'm dealing with, if I have to change the 2, okay, if I'm dealing with decimal place, then I will have to remove that 2 since 2 is lesser than 5. So I'm going to have to change it to 0, and then I'm not going to add anything to the next one. This will just remain 1 the way it is. Okay, that's just a thing about that. So when you're talking about decimal place is different from significant figure. They are very, very different. I'm going to be solving in decimal places and significant figure in this video. Okay, they are very, very different. Yes, alike, they have similarities, but they're different in the way approximate them. Okay, so it is different from decimal place. Then it is also used to express the precision of a number. Okay, if maybe you made some simple calculation, maybe you are doing a mathematics exam or anything, and then you calculated something, the calculator will give you, let's say, gives you 3.09762.5.256.78, and so on. It gives you a lot of numbers. But nobody is gonna ask you to give the results as this. They'll prefer you give them in a precise manner. So that's where this approximation and all of this, decimal place, significant figure, that's where they come in. So we need you to give us in a precise manner. We don't want all this long process. So in how many decimal places do they want it? They say they want it in 2 decimal places, that is to be 43.0. Okay, this 7 is going to be down to 0, and then we're going to add 1 to this 9, which will make it 10, then add 1 to it to get to 1. So it will be 43.1. If we're going to be doing it in 2 decimal places, 43.10, okay, which is automatically 43.1. Then if we want to do it in, let's say, 1 decimal place, or let's 3 decimal place, we're going to be 3 decimal place of 43.098 to be 43.098, because this is 6 right here. It is greater than 4. Okay, greater than 4 or greater than 5. So anything less than 5, you won't add 1 to the next one. You just leave it the way it is, and then turn that thing that is lesser than 5 turn into 0. Okay, that's what we do there. So it's going to be quite simple. So let me move on. Okay. Yeah. Now, rules in significant figure. There are some simple rules in significant figure. Some rules that are very, very important in significant figure. That is why significant figure is different from decimal place. So if we have to round any number, we have to change it to maybe a particular significant figure, you must follow the rules. If you don't follow the rules, you won't be able to get it. Now, the first rule here is that all non-zero digits are significant. Like I said before, non-zero digits are significant. That is 1, 2, 3, 4, 5, 6, 7, 8, 9. All those digits, they are all significant. They are all useful. They're not useless. Okay, that's one rule. The other rule is that the zeros between non-zero digits. Okay, this part is what I'm talking about here. Zeros between non-zero digits are significant. Zeros between non-zero digits, meaning if I have 4 and I have 0, and I have another 0, let's say I have 0, I have 2 at the end of it. And if I want to count how many significant figures do I have in this number, there's no decimal on it, but let's just say this is what it is: 4002. That's 4002. If I have to count the total number of significant figures that are there, since this 0 is in between the numbers, okay, then my significant figures are 1, 2, 3, and 4. That means I have 4 significant figures there. The reason being that the 0 is in between the numbers. So the 0 in between the numbers, they are counted for in significant figure. So 4 of them. Well, if I make it this way, if I have, let's say 4 points, okay, not on 4, let's go with 0. 0.012. Now, if I want to count how many significant figures I have here, now these 0 are not in between numbers. So because they are not in this, there's a decimal point here, please. If they are not in between the numbers, then these are the significant figure. I only have 2 significant figures here. These zeros here, they are not significant. They're not in between the numbers, so they are not significant. Although there's an exception for it in some cases, which I will get to. Okay, so all this. Now, the next part is leading zeros are not significant. Okay. Now, when they say leading zeros, when they say leading zeros are not significant. It means that if I have, say I have 4, 0, I have another 0, I have a decimal right here, decimal point, I have 0, I have 0 all the way. It means all the zeros right here, they are not significant at all. The only thing that's significant is this guy, right? The only thing significant is this. So in this problem here, okay, in this problem here, we have 3 significant figures, which is 4, 0, 0. But the zeros after the decimal, without any numbers. If I have 1 right here, then it's a different ball game. But since I don't have anything there, then all these little zeros are not significant. That is what it means. So, what about trailing zeros? When you say trailing zeros, are not significant if the number contains a decimal point at the end, right? I mean, trailing zeros are significant if the number contains a decimal point at the end. So if call this 4, 0, 0, decimal 0, let's call this 0, okay? Yeah, let me leave it this way, just like the previous one. Now, if they say trailing zeros are significant if the number contains a decimal point, meaning these zeros here, they are significant if there's a decimal point at the end. So these guys are significant only if you have a number in front of them. Okay, these guys are significant. These guys are not significant. But if I change the ball game, then I have, say I have 1 at the end of this piece here. If I have 1 here, then how many significant figures do I have there? I have, this is 1 significant figure, 2, 3, 4, 5, and 6. So I have 6 significant figures. The reason being that the zeros are in between numbers. But if I remove the 1, then the only significant figure I have is 1, 2, and 3 before the decimal. That is 400. Then the 2 zeros after the decimal will be insignificant. So those are the 4 rules in significant figure. So let me take it on this. So just try to understand the rule. You can pause it a little bit, read through the rules, try to get it. If you don't get it, go back to the video a little bit, check it, then you can continue. Although the examples will make it very clear. The examples we have in this video are going to make it much more clearer to you, because just talking without showing you how it's actually done, it doesn't cut it at all. So the best is just to show you, just to do it, and then you get to understand it with a lot of examples. Okay, so examples is this, as you can see, 123.45. Now this is 123.45. Okay, if you want to call it, you call the number the way it is before the decimal. So after the decimal, you call it a digit. So if I want to call this first example is 123.45. Now, how many significant figures do we have? We have 5 significant figures. 5 significant figure, meaning 1, 2, 3, 4. Okay, let me use a dot instead of a line. So 1, 2, 3, 4, 5. Five significant figure. Doesn't matter the decimal, just how many non-zero digit number do we have there? So we have 5 of them. As you can see there, it's 5 of them. Okay. look at this one. How many zero digits do I have? You can see there's 0 at the beginning. There's decimal after the 0, and then 0 follows the decimal, and then 1, 2, 3. How many significant figures do I have there? 1, 2, and then 3. I have 3 significant figures here. 3 numbers. Now look at this one too. I have 1, 2, 3, 4. 4 significant figures. Meaning 1200, because of in 1200, in any whole numbers, if I write ordinary, let's say I wrote ordinary 5 and 5.0, 5 and 5.0 are actually the same thing. They are the same thing. These two guys are the same. Okay, they are the same thing. The only issue is the 0 that's the other one have at the end of it, but they are actually the same thing. This 5 and 5.0 are the same thing, but instead of writing 5.0, because this 0 here is insignificant, so we just decide to just write 5. So 5.0 and 5, they are the same. So what I'm actually trying to get at here is that 1200 have a decimal at the end of it, which obeys the rule of trailing zeros. Okay, it follows the rule of this trailing zeros. Now this 0 after this 1 and 2 are trailing zeros before the decimal point. So there's a decimal point at the end of 1200 before all the zeros that follow it, and all those zeros, they are insignificant. Okay, so they're insignificant. Hope you are following this video. Okay, this work is actually very, very easy. So they're insignificant. Now let me take you out to the next example, which is 45.024. 45.024, if I have to count the significant figures that are there, as you can see, 1, 2. Now the 0 is in between the numbers. Doesn't matter how the decimal point that is with it, but the 0 is there, and then we have to count that 0 with it. This is 1, 2, 3, 4, and 5. So there are 5 significant figures in 45.024. 5 of them. Okay, I hope that is clear. Alright, so it's quite simple. I hope it's clear. So the next part, I'm going to be taking you on various examples on this significant figure. So try to just follow me. I'll take as much example on this significant figure. Now, as you well know, this is an interactive class. It is not pre-recorded or anything. I'm just doing it raw, so just bear with me as I am taking it one after the other. So, conversion of numbers to significant figure. So, in this video, I'm not going to be writing significant figure all the time again. Okay, I'm only going to be writing SF. Instead of writing significant figure, I'll be using SF. Okay, I'll be using SF so the writing significant figure. So let's move on. Now you have to change 0.030068 to first significant figure, second very significant figure, and the third 2 significant figure. So the answers to these are, as you can see, if I had to change it to 4th significant figure, if I'm going to move it to 4th significant figure, these 2 zeros at the beginning, they are not significant, but the zero in between the numbers are significant. So if I want to do it with four significant figure, this is my first significant figure, my second significant figure, my third significant figure, and my fourth significant figure. So the trick in significant figure is that if you have to approximate the significant figure, you use the number beside where you are stopping that significant figure. Like for instance, if I have 0, okay, sorry. For instance, if I have, let's say, if I have 0 point, say 0.24, 0.24, 3, and 5. Or let me change this one to 4. Let's change this to 4. Yeah. Now, and now I want to change this to, let's say I want to change it to 3 significant figure. That means this first, before this, and this is first significant figure, second significant figure, and then the third significant figure. So I want to change it to 3 significant figure. That means I will use this 5 to round up this 4. And then my result is going to be 0.245. 0.245. But if I had to do it to, let's say I want to do it to, so I want to do it to 2 significant figure, to SF, 2 significant figure. I want to do it to 2 significant figure, to SF. Now, if I want to do it to 2 significant figure, it's a bit different from doing it to this. To be different from doing it to 3 significant figure. 2 significant figure will be, this is my first significant figure, my second significant figure. This is where I'm stopping. This 4 right here. This is where I'm stopping the significant figure. So I have to approximate. Now, if it's a decimal place we're working on, we have to approximate from the back, and then come here. And the next one, this one now becomes 5. But the difference in a significant figure, you use the number beside where you want to stop. This is where we're stopping. This 4 right here. If we're stopping on this 4, then we are using this number beside it to approximate it. We don't care. We are not bothered about this 5 at all. In significant figure, you have counted where you want to stop your significant figure. This is the first significant figure. This is the second significant figure. That's where you want to stop. So you use the number beside where you want to stop your significant figure to approximate the next one. So you use it to change the next one. So this next one now becomes 5. So our answer is going to be 0.2. Okay, sorry. Let me take it backward. This 4 is lesser than 5. So if it's lesser than 5, you will have to just remove the 4 and you add nothing to this one. So our answer is going to be 0.24. Okay, I hope that is clear. Please, if there's any confusion, please, I need you to understand it quite well. Okay, the answer is going to be 0.24 if it's going to be 2 significant figure, not 0.25. Okay, if it's going to be 3 significant figure, then this 5 is what we're going to use to approximate it. So because it is 5, which is greater than 4, then we add 1 to this. We add 1 to the next one here, which will make it 0.245. But if it's 2 significant figure, then we're stopping at this one. We start with this first significant figure, then this second significant figure. This is where we're stopping. If we're stopping there, then we use the next number beside it to approximate it. We don't care about whatever is next to it. The number beside it, that's the one you use to approximate the next one. So that's why it is resulting in 0.24. I hope that is clear. So let's go back to the example we have. Yes. So back to that example. To change this to four significant figure. We count the significant figure. You can see the number right here. All these zeros here, they are not significant. But this is the number that's significant, the first one, which is 3. Now the zeros I have here are in between the numbers, so we count it. So this is second significant figure, third significant figure, and fourth significant figure. So what's beside the fourth significant figure is 8. So I use 8 to approximate 6. So that means the result is going to be 0.03007, because what is beside the 8 and the 6 is 8. So we use the 8 to approximate the next one. Okay, so that is the answer to 4 significant figure. What about 3 significant figure? Now, if it's going to be 3 significant figure, meaning counting from here again, this is our first significant figure, this is our second significant figure, this is our third significant figure. I don't care about 8 anymore. What I care about now is this 6. That's the one I'll use to approximate the next one. But remember, I'm doing 3 significant figure. That's why I'm using this 6. So to then be, if I use 6 to approximate, since 6 is greater than 4. So if it's greater than 4, then I'll add 1 to the next one. So if I had to write my answer in 3 significant figure, this is what the results would be: 0.0301. Those are the simple tricks to significant figure. It is very, very easy. Okay, now the last one is 2 significant figure. For 2 significant figure, let's first of all count the significant figure. This is 1 and this is 2. What's next to it is 0. So since 0 is next to it, that 0 is what I'll use to approximate the next, but it is 0, not even 5. When it's 4, I'm going to 0 that 4. I won't add anything to this. So this is 0 already, so I'll just remove the 0, and then all the left here is going to be 0. Okay, so that means the result here is going to be 0.30 to 2 significant figure. But 0.30 is still the same thing as 0.3. This 0 here is insignificant. Okay, that's it. That's just it. But let me take it on to the next example, please. Yes, so to the next example. Here you are asked to change 0.006457 into 3 significant figure, 2 significant figure, and 1 significant figure. Okay, this is what it has to change it to. This is what we are changing this. So if we want to do that to 3 significant figure, all these zeros here, they are insignificant. That means this is the 4 significant figure, number 1 significant figure, first one is the first one. Then this is the second one, and this is the third one. So that means I'm using 7 to approximate the next one. Okay, so that means the result is going to be, a result in that point is going to be 0.00646, because 7 is greater than 4. So we need to remove that 7, we're going to round it off. and then I'm going to add 1 to that 5, making it 0.00646. Okay. Now the next one B, which is two significant figure. As you can see, we have here and here. This is the first significant figure, the second significant figure. So I'm using 5 to approximate 4. Okay. So I'll use 5 to do that because 5 is greater than 4, and I'm going to add 1 to this. So I'll add 1 to 4 to make it 5. That's why this is resulting in 0.0065. Okay. And then the other one, which is one significant figure. And this is what I'm talking about. I think we had that in the previous exam. And then we have it here again. So this is what I'm talking about, that since we're doing it to one significant figure, the first significant figure is 6, and we're doing it to one significant figure. So that means we're stopping at 6. So we're stopping at 6. The only thing we're using to approximate anything here is 4. All this rest, 5 and 7, they become irrelevant. So I'll use 4 to change 6. But 4 is not greater than 5. Okay? So 4 is not greater than 5. Then I'm not going to add 1 to it. I'll just turn the 4 to 0. And then the next one here is going to carry same 6. You're not going to add 1 to it because it's lesser than 4. So it will then be 0.00, okay, 6, 0.006. All these first zeros, they are insignificant. Alright. So let me take it to the next one. So yeah, to the next one. Now the next one is change 45682 to 3 significant figure, 2 significant, 1 significant figure. Now the only changes I have in this one compared to the previous one is that this does not have any decimal point, but the decimal point is located at the end right here, like I did when I wrote 4,000. I wrote 4,000 before. I can't remember if it's 4,000, but meaning this 4,000, the decimal point is located at the end. And after the decimal point, we have 00, which are all insignificant. The only significant zeros are these zeros. They're significant. So we have how many significant figures here? 1, 2, 3, 4. Okay. Those are the significant figures in this number. So if I want to change this to significant figure, this 4, there you have it, 45682. So change it 45682 to 3 significant figures. So how do you do that? That would be 45,700. Okay, 45,700. Why did I do it like that? First, count the significant figure. This 4 here is number 1 significant, number 2 significant, and this is number 3 significant. So what is next to it is 8. So if 8 is next to it, then I use 8 to change to the next one, which is 6. Okay, because I'm stopping at the third significant figure. I'm doing 0 significant figure, so I'm stopping at the third significant figure. So 8 is next to that third significant figure. So I use 8 to change 6. Okay, I use the 8 to change the 6. So if I use the 8 to change the 6, that will be 457. Then because it doesn't have any decimal at it at all, the decimal is located at the end of the story. So the rest of them will become 00 because this number itself is not a decimal number. So you can't remove this 8 and 2 like we did for the decimal ones. You can't remove the 8 and 2 and say they are useless. No, it is a big number. It is 45,682. You can't throw 45,600 and tell me you want to approximate it to a lesser number. No, you can only approximate it maybe to nearest thousands, nearest whole number. So which is quite what we are doing, but in this case it's a significant figure. It has a different rules to it. So this 2 zeros, okay, are this 8 and 2, but they have been zeroed off so that we can have a more precise answer, which is 45,700. Okay. So if we have to do two significant figure, as you can see, it's going to be 46,000. Why? Because this two significant figure, which we're doing it to, we have to count the significant figures 1 and 2. But what is next to the second significant figure? 6. So we use 6 to change 5. So because 6 is greater than 4, then we use that 6 to change the 5 and we add 1 to it. Okay, if it's exactly 4, we're not going to add 1 to it. But if it's greater than 4, we're adding 1 to it. If it's exactly 4 or lesser than 4, or anything lesser than 5, we're not going to add 1 to the next number. But this is 6 right here, so we're going to add 1 to the next number. That is why it is resulting in 46,000. Okay? That's why it's ending in 46,000. So the next, which is a one significant figure, as you can guess, this is what we're gonna have: 50,000. That is one significant figure, which is rounding off from that 5 and then changing 4 to 5. 50,000. Yeah, so let me move on to 793.48. 3 significant figure, 2 significant figure, and 1 significant figure. So this is having a number at the beginning before the decimal point. So if you want to change it to 3 significant figure, that means you have to count the number, the non-zero digits. So it doesn't matter where it is placed, you have to count it. So the first one is 7, second one here is 9, and the third one is 3. So that's where we're stopping. We're stopping there, then we're using this for to change our 3. It doesn't matter the decimal that is here. It does not matter. So we're using the 4 to change 3. So because 4 is less than 5, so we're not going to add 1 to 3. It is just going to be 7, 9, 3. That's the 3 significant figure. So let's see what our answer gives us, which is 793. So 2 significant figure will just be 79. Okay. 79 to 2 significant figure. Oh, 790. Because it's a whole number. Sorry about that, please. It's a whole number, so it's going to be 790, not 79. If it's going to be 79, then the decimal will have to be before the 3. So it will be 790, not 79. So after the 0, you have decimal. So the decimal, and after the decimal, you have zeros. All those other numbers have been zeroed off. So after the decimal, any other number, any other 0 after the decimal without any other number replacing them, every of those zeros, they are insignificant. So this will be 790 because we've turned the 3 into 0. Now the third one is 1 significant figure. As you can see, that is 800. Okay. So let me take it. So to the next one. Okay. which is 0.75128. Now change this one to 4 significant figure. To change this to 4 significant figure, like you see here. Now we count the significant figure. This 0 here is not significant at all. Okay, we're not gonna count it, but this is the first one, second one, third one, and fourth one. So our answer to 4 significant figure is going to be 0.7513, because we're going to use 2 to change. We're going to use 8 to change 2, because 8 is greater than 4, and we add 1 to 2 to make it 3. Okay, so see the answer in a moment. So we can see 0.7513. So 3 significant figure, we're stopping at 1. And what we have beside the 1, or you can say next to the 1, is 2. So 2 is lesser than 4, or you can say lesser than 5. So we're not going to add 1 to the previous digits, okay, which is 1. So the result here to 3 significant figure will be 0.751. Okay, for the third one, which is 2 significant figure. To do 2 significant figure, how many? That's 1, 2, 2. We're stopping at 5. So if we're stopping at 5, so what is next to 5 is 1. Then we use that 1 to approximate the 5. But the 1 is lesser than 5. So we're not going to add 1 to 5. We're just going to write it like that. Okay? Which is what we have, 0.75. Okay, I hope this is clear. It is quite easy. So you can feel free to check this one out yourself. It says 14.0645. Okay, feel free to do this yourself. Once you've done, you can pause the video, do it on a sheet of paper, and then check the answer. Once you're done, you can play it back and check the answer if you're right or wrong. Right, so that is the answer there. Okay, it is for the first one, 5 significant figure. It is 14.065. If you look at it very well, you're doing it to 5 significant figure. So if you're doing it to 5 significant figure, that is, this is the first significant figure, the second significant figure. Since the 0 is in between the numbers, we're going to count it. So this will be the third significant figure, and this will be the fourth significant figure, and this will be the fifth significant figure. So we are using the number next to the fifth significant figure, which is 5, to change our fifth significant figure. So that's why we are resulting in 5 here. Okay, now to 4 significant figure, we added the first stop at 6. So we use 4 to change the next one. Okay, it is very simple. Now you can also check this one out too. You can pause the video and then replay it back after you're done solving it. So replay it back and check the answer if you're right or wrong. So here, these are the answers to them. The first one to 5 significant figure, which the zeros in between the numbers are counted. So that's 1.0508. The 4 significant figure will be 1.051. We're using the 8 to approximate and change that 0 to 1. 3 significant figure will be 1.05. Okay, what is next to the 5 is 0. Then the last one is 1 significant figure. 1 significant figure is going to be 1, because that's the only significant figure we have there as first one, which is 1. So what number is next to it is 0. So we use that 0 to change it, but 0 is lesser than 5, so we're not going to add 1 to the one that is at the first significant figure. So the answer there is just 1. So thanks for watching, and I hope you've been able to get the aspect of this significant figure. It is not difficult at all. So you can take your mathematics textbook, ask question, whatever question it is, use this to solve them. Any problem you have, you can come back to the video. Most of the numbers I've run through all of them, so it will be easier for you to deal with whatever question is given to you in your test, your exam, your classwork, your assignment, anything. To be very, very much easier for you to understand it yourself.